Assalamu alaikum wa rahmatullahi wa barakatuh. I'm just beginning the second part for geometric distributions. Now, let me show you a question. How do you know this question is actually a geometric distribution question, right? Now, look, a dice is rolled until a six is obtained, right? You know, uh, okay, so they keep on rolling a dice until a six is obtained. Now, what we have to find the probability that six is obtained on the fourth try, right? Now, how do I know this is a geometric distribution question? The first condition, it is a repeated experiment. We know from the question that they're going to keep on rolling the dice until a six is obtained, right? So the first condition is true, right? And yes, there's a success and failure as well. There's a success and failure concept for success and failure as well. The value for p is going to be 1 over 6. The reason being, um, and obviously q is going to be 5 over 6, right? Because that is just what the standard probability is for a dice, right? 1 over 6 total. We've already talked about that. I'm not going to be mentioning that again. We have got ourselves a P and a Q, and yes, there are discrete outcomes. You may get a 6 or you may not get a 6. You may get a 1 or a 2 or a 3 or a 4 or a 5. A total of 6 favorable, a total of 6 outcomes, right? Now, these are discrete outcomes. It's not like you cannot count them, you know. An integer number can represent, these outcomes. Now, for the third, well, yeah, all of the conditions have been talked about. And now the last one, there we don't know the value of n. They never said that the experiment is going to be repeated 10 times or 20 times, right? In that case, it would have been binomial. But in here, they just said that the dice is being rolled. We don't know how many times we're going to roll it, but we're just going to keep on rolling it until we receive a six. We're going to keep on doing it until we receive a six, right? Now that's a geometric distribution question. Now that we are sure that this question actually is a geometric distribution question, this is what we are going to do. Find the probability that 6 is obtained on the fourth try. These are the kinds of questions they're going to ask you in, by geometric distribution questions, right? So so the probability that we are going to find is that a 6 is obtained on the fourth try, right? Which means, they threw the dice once, the first try, then the second try, then the third try. In all of these tries, they failed, right? So sorry, they didn't get a six, right? But on the fourth try, they did get a six, right? So three failures and one success. I told you when events are happening back to back consecutively, one after the other, you multiply these events in order to find the total probability, right? So the probability of obtaining a six on the fourth try would be, at first you've got three failures, right? So you've got three Qs. The value for Q is 5 over 6 multiplied by 5 over 6. That was a pretty weird 5 over 6 times 5 over 6, right? And then on the fourth try, we got ourselves 1 over 6, right? So in the marking schemes, you might also sometimes see 5 over 6, this, multiplied by 1 over 6, right? This is going to be your answer. Again, I'm lazy. I forgot to, take my calculator with me. So I'm not going to be calculating it for you right now, but this is how you find it, right? It was this simple. This is how geometric distribution is more closer to common sense than, the Cambridge International A and AS level syllabus or curriculum. It's just a simple thing. If you want to find the probability that a dice that is being rolled until a six is obtained, if you want to find the probability that that dice is going to give you a six on the fourth try, then all you have to do is imagine first three tries were failures. So you write 5 over 6 multiplied by 5 over 6 multiplied by 5 over 6, right? And the fourth try would be the success. So that would be 1 over 6. And then you just multiply all of them together, you get yourself the answer. Okay, that's it. Now is the right time to know the formula for this. And the formula for this is P x is equal to R is equal to Q R minus 1 multiplied by P. This is the formula for geometric distribution. Okay, this is the formula for geometric distribution. Now, what is, you already know what is P? What is P? P is the probability for success. Q is the probability for failure. And now, what is R? Right? R is the th try. Right? You know. For example, in this question, what was R? 4 was R, right? So if I was to try to solve the question, this same question with this formula, this is how I'm going to do it. P x is equal to R, or in this case, that's a 4, right? 5 over 6, the probability of failure, right? Times 4 minus 1, that would be 3 times 1 over 6. We're getting the same answer, aren't we? Right? We are getting the same answer. So this is how it works. The R in here is just the nth try on which you want the success to happen, and then obviously the experiment is going to end, because the moment you get your first success, you're just done with it, right? You're just done with the experiment. Now there are a couple of more formulas for this, and we're going to learn about them and their questions later on. Okay, but that was it for today's lecture.